Okay, hi there. Now this next one, 97, is going to be, well, probably more than one session, and I'm going to be doing it in parts. And one of the parts is to, well, first, all of my projects for quite a while now have had this flag set in the compiler settings, and that enables what I found out were all of the warnings, compiler warnings, that are disabled by default. Some of those warnings are quite important, and this is one of them. Construction of local static object is not thread safe. However, we haven't discussed thread safety or threading issues really, except for that one little example. And so part of this set is going to be on that. So I'm just going to do this in, like I said, in parts, and then glue these little bits together. And so the first part will be on thread safety, mutexes, critical sections, all that sort of stuff. So I'm going to see what I can come up with for that first, and then I'll explain what this is. Okay, now part 2. I'm trying to develop a situation here where we have two threads going. I'm going back to our marshalling thing. I've added a second put S2. Now the first one waited for the call to complete and returned a value. This second one just posts the message and then goes away. So therefore, whatever string is contained within the message, we want to survive in order so that these calls can complete successfully. Now for the old sync, now that I've changed the thread proc, so we're following away. Again, if it's signaled to quit, it just quits, no matter what's in the message queue. Otherwise, there's a message or more than one message in the queue, and I'm going to remove all messages doing this loop. Peak message. Get message is no good because that'll hang. But peak message with remove will remove all the messages and eventually return 0 and quit, which will put us back at our wait. If the message is invoke call, that's the synchronous call, I should call this sync call. I make a little note of that, invoke the call, and then signal its completion. If it's an async call, I make a note of that, invoke, and then I add that call to a list. And once this whole loop is complete, then I go through that. I've changed the ordering of this. I was invoking them here, but now I'm invoking them during the loop, so I'll change this message just to be deleted. I don't really need such a big message and all that, but it's okay. Now, first, let me just get rid of this catch here. In my loop here, in my main loop, I go 5,000 times R. Every time, or randomly, if the rand returns a multiple of 100, I do 5 synchronous calls with some random letters and things, and continue on. And for the asynchronous calls, I create I allocate a string object. I call the no wait version of the function, and I add that pointer to string to a list because I don't want it to get deleted before the call gets invoked. Otherwise, the string will be no good. And then at the end, I go ahead and delete everything in that list. Now, if there's no waiting here, you can see something bad happen. Should happen. Nothing bad really happened, did it? Let me put this down here. Maybe punching them up made it more likely for badness to happen. Okay, we got some badness at the end here. But I can make that more likely if I return to what I was doing. So if I'm going through the loop and I'm bunching them up, that costs time, and that might be just enough time to allow for the other thread to go ahead and start deleting the string. Well, it only seemed to happen at the end. Huh? Now these ones got deleted. It's only going to happen at the end. Nothing bad should happen before the end. But how about to be more likely? So maybe if I spend less time doing that. See, these occur instantly. If I don't put anything at all, that's pretty bad this time. Yeah, a lot. No, this happened this happened before any synchronous calling. So this was going through its asynchronous calls when suddenly all the strings die. And then it still had more asynchronous calls in the message queue. next time around. So that's more badness. If I don't put this here in at all, it should be all badness. Because I'm just going to immediately delete the string before it gets a chance to print any of them out. And sometimes I can actually get a hey, look, I got an actual character. So like a few of them got invoked because it took time to go through that loop. And while it was queuing up messages in this loop, right, 5,000 of them, it had enough. The other thread had enough time to print out this many, and then it just died. Well, it didn't die, but let's always CC or GC. Yeah. They were all the same length. I can mix that up a little bit. So all badness. It should have a few though at the beginning, yeah. The last one that was good was that one. Okay, now what I want to do is put this back again. Because there's pausing here, right? If there's a great big, although the synchronous ones are done during the loop, they don't have to wait. No, it's still got to wait till the next one. Okay, we lost a bit more. Okay, so now it again happened right after a synchronous call. It doesn't have to. Let's see if that can occur. Or maybe it does have to. No. There was no asynchronous call. There was no synchronous call here. All it happened, it had completed its current list of asyncs, and then by the time it got to the next bunch, it was dead. But still, I'd like to see if it can happen while it's doing the asynchronous loop. Or maybe. Yeah, here we go. So it's trying to do 26 call, and midway through, everything got deleted. Okay, now whatever was left is also dead. You might think that since this thing is going to be at the end of the list, right, presumably, since all of these have been posted, that everything should be completed and done by the time I get to here. Well, let's see if that's true. but it wasn't, you see? We're going to get back here. That is the mystery question. How come this sync print, well, let's see if we even see, we should see that sync print somewhere. Should be the last thing we see. Here it is. But no. You see? This got posted on the queue, and yet there were still more messages bunched up that hadn't been printed, that hadn't been processed yet. That is, because this is multi-threading, right? A context switch can occur at any time. Okay, so that means when we're at this point, we're waiting to do our sync print, or waiting for our sync print to complete. A context switch could occur such that, yeah, that's not it. What obviously it's in the printing loop. These invocations happen before the asynchronous ones. So the synchronous ones happen first. Down here, we have the synchronous print. So this synchronous print would have occurred before any asynchronous prints that happened to be in the message queue at the time when this was posted. So, in every case should end in the same way. If it crashes, dies, or does whatever it does, it should do it exactly the same way. Sync print, then it's going on to the rest of them, and then it dies. Again. Sync print, dies. And it's always going to be the last message you're going to see is not necessarily sync print, but it'll be the last one before it starts the next loop of asynchronous. If there is a next loop of asynchronous one. If there isn't, then everything will be fine. Sync print, asynchronous loop. Now, I'm curious about these GCs. It's either GC and now it's an H. There's something strange about these letters. What's G and C? $47, $43. Not very informative. So that's one of the mysteries anyway. The other thing's not a mystery. No, it worked this time. There were only a couple left. So everything was fine. Sync print die. And always ending with GC. So there's a mystery for you. Why we then with GC? Remember that it's called info and the printf first. And pointer to a function. And the pointer function is put TTS1 /n %d. Oh, thread ID. Something to do with that part. There's stir, which is random garbage. A colon. No. Okay, well, that's a mystery. Try and figure it out. Okay, so I'll try and add some more confusion to the mess, and then we'll talk about synchronizing threads. and if I get lucky before this gets posted, I'll be able to get a crash. And it should be possible. I've gotten a crash. I mean, like a hardware crash. Because of multiple access to the same pointer. But I'm not sure why. But anyway, okay. So till next time. Well, I figured out the answer to that question. If I put a breakpoint here, okay, now there should be a bunch of asyncs in the queue, which are going to wind up here. Oh, well, that one survived. Okay. Now, you'll notice that this block is of a certain size. It doesn't say the length of it, but you can see the next one will be the same size. See? And they're all the same size. And they're all deleted memory. And following the deleted memory, the last FE is a data structure which has to do with the runtime library. And the first time you run into a double zero happens to be here, and preceding that double zero is a 4743. Now, I believe that has to do with the size of this block. The fact that they're all the same size. Gives you the same ending characters. See that %s is going to end up with a 4743. If instead I randomize the size of these ones, wait a minute. Those weren't 12. Why were they all the same size? Okay, it's still a mystery. What is that length? This is not the same stuff. This one's not going to say GC. Okay. Then it's not a property to do with the size, but a property to do with this data structure that has to do with, must be to do with the runtime library. And it's debug malloc. If I use a different version of malloc, then it won't. This probably won't be consistent. If I compile this for release, yeah, help me. Well, putting breakpoints is useless. Release 1. But I don't expect to see the same last two characters, because it's using a different form of malloc. And we may actually see some crashing. Here's the error. Comment.h. Well, that's odd. That's a mistake. We'll see what happens. What's the worst that can happen? The machine crashes and I lose this video. It's fast enough. It's fast enough. Speed is of the essence when it comes to this. Oh, actually, those could be deleted because the release version of the runtime doesn't clear out the memory when you delete it. Doesn't do anything with it. Just leaves it. So I would have to go to some lengths. You can see these are not from the right character set. So that's definitely deleted memory. Okay, this first one might be alright, but whatever's ending up in here, it's just garbage, something else happening. So that's the answer. Alright.